In the early 2000s, two facts were universally accepted as absolute truth. First, electric vehicles were practically glorified golf carts, slow, ugly, and entirely impractical. Second, space exploration was a stagnant, slow-moving monopoly reserved strictly for massive government agencies. Breaking into either of these hardware sectors meant facing impossibly high walls. A newcomer needed billions in upfront capital and access to highly specialized, deeply entrenched supply chains, effectively locking out any private competition. Enter Elon Musk. Armed with his recent dot-com earnings, he made the highly counterintuitive decision to tackle both of these colossal industries at the exact same time. By every conventional business metric and historical precedent, attempting to build an independent car company and a private rocket company simultaneously was a guarantee of total financial ruin. And reality quickly caught up. SpaceX's initial attempts to reach orbit ended in highly public catastrophic explosions. Meanwhile, Tesla was stuck in a brutal prototype phase. The team faced severe bottlenecks as they struggled to scale up battery production and figure out how to reliably manufacture the vehicles. Cash burned fast. Both companies were bleeding millions of dollars and sitting just days away from completely running out of money. So how does an outsider, facing market rejection and imminent financial collapse, survive to reshape human transportation and space travel? Musk began applying a radical, uncompromising cognitive framework to pull both companies back from the edge of total collapse. It comes down to first principles thinking. Most people use analogical thinking. They look at current methods, copy the model, and try making small improvements. In aerospace, that meant assuming a rocket had to cost hundreds of millions of dollars, simply because legacy contractors had always charged those astronomical prices. Musk looked at bare physical truths. Stripping a rocket to elemental materials, aluminum, titanium, carbon fiber, reveals their exact open market value. The chart shows this revelation. The raw materials bar is dwarfed by the massive legacy price. Materials are only 2% of final cost. That vast gap in the math proved one thing. Building rockets entirely from scratch was the only logical way forward. This exact logic carried over to the automotive side. By pricing out the raw base metals of a battery rather than buying pre-made packs from traditional suppliers, Tesla bypassed the accepted market costs that made electric cars prohibitively expensive. But identifying a mathematical truth is useless if you cannot actually build the machine. You have to get your hands dirty. This required an aggressive, engineering-driven leadership style. Instead of managing from a boardroom, Musk practically lived on the factory floor, working directly with engineering teams to solve mechanical bottlenecks in real time. That direct intervention on the line allowed Tesla to tear up the traditional automotive supply chain and construct an entirely new manufacturing process from the ground up. Extreme disruption requires leaders who treat corporate strategy as an engineering problem to be solved with technical rigor. Pushing through this brutal rebuild phase required an extreme tolerance for risk. Those early rocket explosions and production line failures were not viewed as defeats. They were treated as aggressive investments to gather unique, critical data. This graph shows how that philosophy plays out. The sharp drops represent short-term failures, but when the end goal is treated as a physical requirement, every explosion becomes a necessary data point. This fixed long-term objective justifies the technical chaos of the present. It also required taking early profits and relentlessly feeding them right back into research and development, completely ignoring the safety of traditional dividends. Extreme technical and financial hazards stop being reckless when they become a mathematical necessity to break an industry wide open. The ultimate validation arrived in orbit. SpaceX drastically cut the cost of launches and achieved what only governments had done before, delivering astronauts to the International Space Station. Back on Earth, Tesla survived its financial valley of death to become the top manufacturer of electric vehicles globally, forcing every legacy automaker into a clean energy arms race. Today, that exact same analytical method is being deployed to build global satellite internet networks and advance neural interface research. What happened here is a replicable playbook capable of dismantling completely unrelated legacy systems. Operating at this velocity comes with heavy externalities. It requires navigating extreme financial volatility, demands a relentless work culture, and accelerates systemic anxieties regarding automation replacing human labor. But it proves a harsh reality. Massive technological leaps do not emerge from safe, incremental adjustments to the status quo. Pushing the world forward requires the willingness to strip reality down to its absolute truths and the sheer persistence to survive the risks it takes to rebuild it.